Okay, for our next problem, we have the data from a falling head test are given below. We have the diameter of standpipe, the initial head difference, the final head difference, the duration of the test, the length of soil sample, and the diameter of permeameter or the soil sample used in this test. And then we are required to get the value of these unknown parameters. So first one is the coefficient of permeability or the value of K, hydraulic conductivity. And the value of K or hydraulic conductivity for falling head test is equivalent to A L over AT ln of H1 over H2. A being the cross-sectional area of the pipe used in the test, L being the length of the specimen used, A is the cross-sectional area of the specimen used, and then T is the duration of the test, H1 is the initial head difference of the water levels, and then H2 is the final head difference of the water level graduations in our test. And then, again, parang yung first problem kanina, pag sinabing laboratory test ng permeability, palaging direct substitution. Ang babantay lang natin mismo dito ay yung consistency of units. So, K is equivalent to A cross-sectional area of the pipe used. Kung mapapansin natin dito, meron tayong diameter. So, that is a circular section. And then, naka-millimeters. So, para maging consistent yung units natin, since naka-cm lahat dito, gawin natin siyang centimeters. And that is equivalent to 0.6 centimeters. So, substituting area of circle, pi over 4 times the diameter, 0.6 centimeter quantity squared, multiplied by L, the length of the specimen, given in the problem, 30 cm, over A, that is the cross-sectional area of the specimen used. We have the diameter of the specimen, 40 cm, therefore circular area, also pi over 4, 40 cm quantity squared. The duration of the test, 12 minutes, multiplied by the ln of the quantity, initial head difference, 92 cm over 85 centimeters. So, cancel na to. Cancel. Cancel yung units. Cancel yung pi over 4. And then, yung unit natin magiging centimeter per minute. So, computing for the value of K will be equivalent to 0.0000445 centimeter per minute. And that will be our first requirement. Second requirement, hydraulic gradient. And the hydraulic gradient for a falling head test is the head loss over the length of a specimen. And head loss is equivalent to the difference of the initial head difference and the final head difference. And that is over the length of the specimen. So, substituting, we'll get I equivalent to H1, 92 centimeters, minus H2, 85 centimeters, over L, the length is 30 centimeters. So, I will be equivalent to 0.23, and that is dimensionless. And then the third requirement is the rate of flow of water in the soil. And the formula of flow rate is Q is equivalent to K multiplied by I multiplied by A. So substituting, we'll get a flow rate of K, already computed, 0.000445 centimeter per minute, multiplied by I, hydraulic gradient of 0.23, A, the cross-sectional area of the specimen, pi over 4, the diameter is 40 centimeter quantity squared. So since wala namang units na binigay, we will stick with our unit here, cubic centimeter per minute, and we will get a value of Q, which is 0.01305 cubic centimeter per minute. Third requirement. Fourth requirement is to compute the seepage velocity if the porosity of the soil is given. And then seepage velocity is the ratio of discharge with respect to the porosity. So substituting, discharge velocity is the product of hydraulic conductivity Ni, hydraulic gradient over N. So substituting, this 0.000445 centimeter per minute multiplied by 0.23 over porosity given in the problem, 0.25. So computing, we will get a value of seepage velocity of 0.000178 centimeter per minute. And that is our fourth requirement. And then the last requirement is determine the coefficient of permeability if the temperature during measurement was 22 degrees Celsius. Okay, so meron tayong temperature correction na gagamitin dahil when conducting this laboratory test, dapat ang baseline temperature natin ay 20 degrees Celsius. So, ibig sabihin, na-compute natin dito na value ng K or hydraulic conductivity ay hindi siya naka 20 degrees Celsius. Naka 22 degrees Celsius siya. So, i-correct natin, kukunin natin mismo yung corrected hydraulic conductivity at a temperature of 20 degrees Celsius. So, para makuha natin yon, K corrected, which is at 22 or 20 degrees Celsius, is equivalent to the product of K computed at a temperature 22 degrees Celsius multiplied by the temperature correction. So, meron tayong computed hydraulic conductivity kanina at 22 degrees Celsius. And then, compute na lang natin mismo yung temperature correction. And then, temperature correction is equivalent to 2.42 minus 0.475 ln of T, where T is the temperature in Celsius during measurement. So, substituting 2.42 minus 0.475 ln of 22 degrees Celsius. And we will get a temperature correction of 0.95. So, substituting sa ating formula, K corrected or K at 20 degrees Celsius is equivalent to 0.000445 centimeter per minute multiplied by 0.95. And we will get a corrected hydraulic conductivity of 0.0004237 centimeter per minute. And that will be the requirements for the falling head test for getting the value of permeability of a soil sample.